divided by 1, which is our hypotenuse. And then for tan theta, it's opposite divided by the adjacent. The opposite is negative y. The adjacent is positive x. In the fourth quadrant, realize that it's only cos that's positive. So in this quadrant, realize that all trigonometric ratios were positive. In the second one, realize that it's only sine that was positive. In the fourth one, realize that only tan was positive. And in the fourth one, it was only cos that was positive. So we can remember this using all stars twinkle clear. And you can use any that can help you remember if this won't work. But I prefer to use all stars twinkle clear. All of them are positive in the first quadrant. Only sine is positive in the second quadrant. Only tan is positive in the third quadrant. And only cos is positive in the third quadrant. If that's okay, you can tell me in the chat to go on. Or if you have a question, you can raise your hand. So let's look at a few examples. Let's find the value of sine 125 degrees. This is our unit circle. So we're going to use this to help us label. This is 90. This is 180. This is 270. This is our starting point, which is 360 degrees also. So I told us to find sine of 125 degrees. And we see that it's in the second quadrant because it's greater than 90 but less than 180. Should be around here 125 degrees. This is our 125 degrees. In order to get this angle that lies within the right angle triangle, we shall say 180 degrees minus 125 degrees. Who has our calc? What's 180 minus 125 degrees? So this angle is 55 degrees. So it means that sine of 125 degrees is equal to sine of 55 degrees. You can use your calc to give us the answer here. For me, I found it as 0.819. And if you also input for sine 55, it will give you 0.819. Now let's look at another one. For cos 245 degrees, cos of 245 degrees. So we see that 245 degrees is found within here. This is 245 degrees. In this quadrant, our cos's are negative. Then you can find this theta. By saying 245 degrees minus 180 degrees. Which will give us 65 degrees. So this angle here is 65 degrees. But since our cos is negative, so it will be cos of 65 degrees. Sorry, negative cos of 65 degrees is the same as cos of 245 degrees. Then what's the answer of cos 245 degrees? I'm getting negative 0.4226. Is that fine? Yes. So now we're going to go ahead and look at the trigonometry at the compound angle identities. We're going to look at the compound angle identities. It has the following formula, which you need to master. And then we are going to prove only for tan. But you have to memorize this. Let's first prove for tan. We're going to first prove for tan A plus B. As I said, our tan is the same as sine divided by cos. So we shall have sine the angle remains the same. It will be sine of A plus B divided by cos of A plus B. Then you shall go ahead and open brackets or expand sine A plus B. And now sine A plus B is sine A cos B plus cos A sine B. Divided by, now we are going to expand cos A plus B, the denominator. Cos A plus B is cos A, cos B. Minus sin A sin B. And then in order to get tan, we know the best way we can get tan is by dividing sine with cos, sine over cos. So in this case, we're going to divide through by cos A and cos B. So it will be sine A cos B divided by cos A cos B plus our cos A sin B divided by cos A cos B. What we do in the numerator is what we do in the denominator. So we shall do the same. So cos A cos B divided by cos A cos B as well. Sin A sin B divided by cos A cos B. And then here in the numerator, sin A cos B divided by cos A cos B. Cos B is common, so we cross it out. Then in cos A, sin B divided by cos A cos B. Notice that cos A is common, so they cancel out. And then here, cos A divided by cos B divided by cos A cos B. These two cancel out. I didn't write the denominator. I didn't write the cos A over cos B because of the space here. And then here we have sin A, sin B divided by cos A cos B. There is nothing to cancel out there. So then we shall write again. Here we are left with sin A cos A plus sine B divided by cos B. Divided by 1 minus, here we have sine A sine B divided by cos A cos B. So we have our 1 minus sine A, sorry, this part, so we have our sine A divided by cos A. Our sine divided by cos gives us tan. Plus this part, our sine theta, sorry, sine B divided by cos B gives us tan B. Divided by 1 minus sine A divided by cos A is tan A. And our sine B divided by cos B is tan B. So that's how the compound angle identity for tan comes about. Is that fine? Is that fine, or should we continue?
It's fine.
So let's look at another example, which will need us to use the trigonometric identities. So we have our sine theta as 3 over 5. And we have cos beta as 15 over 13. So 5 over 13. And they are saying that our theta is obtuse and our beta is acute. And without using tables or calculators, find the values of sine theta plus beta also find cos of theta plus beta. Anyone to do for us this number? They are saying given that sine theta equals to 3 over 5 and cos beta equals to 5 over 13, such that theta is obtuse and B is acute. Without using tables or a calculator, find the value of sine theta plus beta. Let me do number 1, then someone to do for us number 2. So they have said that sine theta equals to 3 over 5, but theta is obtuse. If theta is obtuse, that means that it's greater than 90 degrees, but less than 180 degrees. So could be either here. So most probably our theta is this. This is our theta, which is obtuse. So it lies in the second quadrant. So we shall be using our SOHCAHTOA. Sine is opposite divided by hypotenuse. So that means our 3 is the opposite this angle in question here, where you see the arrow. It's 3, and then our hypotenuse is 5. And they've told us to find sine theta plus beta. But first, let's first find this distance here using Pythagoras theorem. Let's call it x. So x squared plus 3 squared gives us 5 squared. So x squared plus 9 equals 25. So x squared in this case equals to 25 minus 9, which is 16. So our x is 4. So after us to find sine theta plus beta. Shall use this part, sine theta plus beta. Which gives us sine theta cos beta plus cos theta sine beta. We have our cos beta, but we don't have our sine beta. So let's first find sine beta. They said that cos beta is 5/13, and they said that beta is acute. If beta is acute, that means it lies within the first quadrant because it's greater than 0, but less than 90 degrees. So it lies within here. So this is our beta. They've said that cos beta equals to 5/13, and cos is adjacent divided by the hypotenuse. So the adjacent is here, which is 5, and the hypotenuse is 13. If we are to do Pythagoras theorem, this part here will be 12. So we're here. Sine theta cos beta plus cos theta sine beta. Working out this question, sine theta plus beta. Our sine theta was given is 3/5, and cos beta is 5/13. Plus our cos theta, shall read it off from the standard position, the xy plane here, the second quadrant. Cos is adjacent divided by the hypotenuse. So the adjacent in this case is 4. and the hypotenuse is 5. And then our sine beta wasn't given, but you can read it off from here. Sine is opposite divided by the hypotenuse. Our opposite in this case is 12 divided by the hypotenuse, which is 13. So when you work out this, it gives us 15 over 65 plus 48 over 65. So our answer will be 63 divided by 65. Is that fine?
Yes, it is.
Okay, someone to do for us the second number, which is cos theta plus beta. Someone to do the next question. The question is given sine theta is 3 over 5, cos beta is 5 over 13. And they're saying that our theta is obtuse and beta is acute. Find cos theta plus beta. Someone to do it. Or someone to guide me to do it.
Madam, I can't write on the screen, but at least I can guide you and be waiting for me, if you don't mind.
Okay.
Let's first expand our question since it is cos theta plus beta. Then let's expand it by saying it is cos theta cos theta cos beta minus sin theta then sin beta. But our theta is obtuse angle. And we know very well that obtuse angles, those are angles between 90 and 180. Also, madam.
Yes.
So we shall draw our and you put where there is between 90 and 180.
Okay, after.
If you draw a triangle, yes. Then our sin theta is 3/5.
Yes.
But sin, according to Sokatowa, sin equals opposite of hypotenuse, meaning 3 is our opposite and 5 is our hypotenuse. Then we name the other one that you are left with x. Using Pythagoras theorem, it is x squared plus 3 squared equals to 5 squared. So x squared equals 25 minus 9.
Yes.
Yes. So our x is x squared equals 16. So our x equals 4. So we've got our x as 4.
Okay.
And now we have our theta. As if we have our theta, we go to beta, madam.
Okay. Yes.
Beta is acute, and acute, those are angles between 0 and 90 degrees.
Correct.
Acute angles, those are angles between 0 and 90 degrees.
Yes.
So, madam, we shall go between 0 and 90 degrees, a triangle. And they have said cos beta equals 5/13, of which cos equals to adjacent over hypotenuse, meaning 5 is adjacent and 13 is hypotenuse.
Yes.
Then you are left with the opposite. Let's call it n later.
Which one?
Let's call it y. So, still Pythagoras theorem, it says that 5 squared plus y squared equals 13 squared. So it is 25 squared plus y squared. Madam, then help me with 13 squared because my calculator has got some problems here.
Okay. $169.
169, yes. Then y squared equals 169 minus 25 is Madam, still help me there. So it's 144.
Yes.
Then our y equals our y is 12. Then we remove y and you put 12.
Yes.
Now, remember we've expanded our question is saying that cos theta, cos beta minus sin theta, sin beta. Meaning,
yes,
we are going to use these triangles. They are going to guide us when we are putting these numbers that we've got here in the equation that we have created. Meaning that cos theta is the same as adjacent. That is theta. This one is beta. Cos theta, the same as adjacent
yes,
over hypotenuse, meaning it will be 4 over 5
yes,
times cos beta. Cos beta, it will be 5 over 13. Minus sin theta is the same as sine is opposite over hypotenuse, meaning our opposite will be 3 over 5. To be 3
okay,
3 over 5. Then times sin beta, the same as opposite. Opposite is 12 over 13. Then with 4 times 5, the same as 20. Then 5 over 13 is 65.
yes,
Minus 36. 36.
okay,
36 over 65. Which is it will be 16 over 65.
you're missing something.
Sorry, madam?
You're missing something.
Then you can guide me, madam.
20 minus 36 will give us a negative.
Sorry?
A negative 16 over 65.
So negative 16. Oh, yeah, it's a negative 16 over 25 over 65. You're right, madam.
Okay, thank you very much.
You're welcome, madam.
Has everyone understood? Yes, mama. Okay. Let's do one more example and you call it a do. The next question will be, prove that So next question is, prove that cos of 25 degrees, cos of 35 degrees minus sine 25 degrees, sine 35 degrees equals to a half. Anyone to help us with this one? Someone help us with that question. The question is, prove that this equals to a half. I'm waiting for your answers. We are using these trigonometric identities to prove that this equation gives us a half. It doesn't need a calculator. Because this time is going, let's work it out like this. So they are giving us cos of 25, cos of 35, minus sine 25 degrees, and sine 35 degrees. So you come here to your trigonometric identities, and you see which one corresponds to cos, cos, minus sine, sine. So let's say cos A, cos B, minus sine A, sine B. So it corresponds to this. So we shall have our cos into 25 plus 35. Which will be cos 60. And that's the answer. We all know cos 60 is a half. Is that clear?
Yes, madam, it's clear.
Okay. I think we have come to the end of today's lesson. Someone to pray for us. Someone to pray for us.